Okay, factoring by grouping, you just group the first two and then the last two. What factors out of the first set of parentheses is x squared, and you're left with x minus 7. If this is factorable, you have to end up with x minus 7 over here. Well, 35 divided by 7, with the signs both being negative, a positive 5 factors out. And always check this. 5 times x is 5x. 5 times negative 7 is negative 35. So it's factored correctly. What's written twice is x minus 7, so you're going to write it down. X squared plus 5 is left over, so it's in the second set of parentheses, and that's factored completely. Number 9, again, you group the first two and the last two. 9x squared comes out first, and you're left with x minus 3. You have to have x minus 3 here as well. And so you had negative 4x plus 12, and you had to have factored out a negative 4 here. And then you check it. Negative 4x is negative 4x. Negative 4 times negative 3 is positive 12. So it's factored, so far it's factored correctly. What's written twice is x minus 3. What's left over is 9x squared minus 4. But that second set of parentheses is a perfect square minus a perfect square, so it factors further. That would be 3x plus 2, 3x minus 2, and it just follows the formula that we know, the difference of perfect squares. Okay. Number 10. Put the first set in parentheses and the last set in parentheses. And what factors out of the first set of parentheses is 25x squared. And you're left with x plus 4. So you know this has to be x plus 4. And everything's exactly the same except for the sign. And when that happens, you factored out a negative 1. So x plus 4 is written twice. 25x squared minus 1 is what's left over. And so that's a perfect square minus a perfect square, and so it fits our formula. That would be 5x plus 1. I messed that up. 5x plus 1 times 5x minus 1. Just remember, on the difference of perfect squares, the 5x times 5x will multiply to give you this one. The last two terms will multiply to give you that one. One has to be positive and one's minus.